Previously on The Bald Engineer.
Oh God, wait a minute, what?
Ooh, you're dirty.
Oh no.
James, you're looking at the wrong chip.
Oh my God. Excuse me.
Farts.
And F stands for fun. Pick. Yep, fell right for that one.
Tab is ground.
Oh no, 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 no.
New work.
Oh my God, are you kidding me?
And R.
Why is it triggering now? That could have gone a little better. All right, let's give this a try. Something is... Hi, I'm James. Welcome to the stream. Something's really, really, really wrong with my setup, and I don't have any idea what. I just thought of something I want to double check. Okay, that looks right. I don't know what's going on. A bunch of things I set last week are no longer set. And for some reason, YouTube wasn't responding until just a few minutes ago. Anyway. So, hi. Hey, Shell Schlock. Good to see you. Laz, nice to see you as well if you're still around. M. Cozy, welcome to the stream that eventually started. Mike, thanks for joining as well. All right. So, here's the thing. I have, not this. So at Teardown a couple of weeks ago, a person named James Wilson was kind enough to give me one of his open sourced active probe designs. This is a 2 gigahertz active probe for oscilloscopes. And if he was to produce it, it would be on the order of like maybe $150, $200 kind of thing. I'm going to round up and say 300 just because sometimes, stuff like that goes weird. But I have only been able to look at it with like a few signals. I would like to be able to characterize it. So I designed this fixture, which we were going to today. Oh, these are the wrong ones. Okay, maybe not with that one. Not that one. This one. I was going to solder on the SMA connectors, run it through a nano VNA to make sure it's a 50 ohm trace. However, I somehow designed the wrong footprint. And what really bothers me about this is I only had one type of SMA connector in my parts bin, and I've used this footprint before, but I can't even find the board that had that footprint and connector that worked before. So I can't even use that board just to take the SMA connectors off of it. Now these others I ended up buying because I wanted more and to try some stuff out, but I'm just really frustrated that my footprint is wrong. So we're going to fix this footprint, and depending on how long that takes, I also want to just start designing a board that will create a 50 picosecond falling edge so that we can get a good step response from the probe. So that's what we're going to do, is I'm going to fix this board. The other thing is, if you look really close, you'll notice, so the way that this was supposed to work was, this was supposed to be a 50 ohm trace. I was going to put SMA on either side so that I could then connect it to the scope and a pulse gen. And then around on either side was ground. And the idea was supposed to be that you could then take and connect the probe onto ground and signal, and then we would be able to see the signal going into the scope, and then we'd also see the signal coming out of the probe so we can compare the two. But I did make a minor mistake, and I didn't even realize I was making this mistake, is I let the ground plane right here on the edge come all the way through. And the problem is the pin on the SMA might actually solder to this little bit right there. So we need to get rid of that. I think I know why I did that. I think I was trying to make it so that there was ground underneath the lip of the connector, but my connectors don't have that lip. So this probe calls for a 3D printed case. Yeah, actually, that was supposed to be what I wanted to do in Rev 2. But yeah, so we're going to fix those things in KiCad. So first what we're going to do is we're going to fix this footprint, and then we're going to fix those things, and then we'll see where we're at. Yeah, so let's go to here. I should be able to press this. We can have this back. And hey, Alex, good to see you as well. Welcome back. So what I need to do is we need to go to, oh, I already closed it. Oh, I know why. I need to projects, test tools. What I want to do is save a copy of the old project so that I don't, well, because I like to, ball probe test fixture. Then let's just do this because that kind of hides those things. All right, so we're going to come in here and I'm going to create a new folder. I'm going to call it Rev1, and then we're going to move, we're going to copy the KiCad files to Rev1. I'm going to delete the backups because they don't matter. We're going to rename the gerbs. Actually, the gerbs we're just going to, actually we're just going to delete them. Oh, it already has the file name in them. Yeah, we're just going to delete them. I can always roll back. I don't like to rely on Git to go to a previous board revision just because it kind of gets messy sometimes, and I just would prefer to have, like, okay, I submitted this to the fab, that version separate. I don't know. I still make a lot of Git mistakes. It's almost like I went to school to be a hardware engineer and they didn't teach us how to use a version control system that didn't exist yet. It's a really strange how that worked out, really strange. Okay, so now that that's done, let's come over here. And what I should have done is branched the project, but oh well. Prep Rev 2. Hey, Mr. Debug, thanks for coming by. Sorry you have to work early. I dislike working early as well. All right, so that should be taken care of now. So now I can open this up in the KiCad and we can get going. Also, I'm super glad to see that YouTube finally started working. So here's this super complicated schematic that I was using. I even checked to make sure that this would pass DRC or ERC. And in fact, maybe I didn't. Yeah. Powers, yeah, I don't care. Okay, so here's the thing. Yep, that is not the part number that I'm using. Yeah, footprint is close to existing stock, but not exact. Yeah, it's not even close. What was I smoking something when I did this? Oh, here's what I'm looking for. I wanted to use this package of SMA connectors because, yeah, so we're going to come back to this real quick. Let's just go over here. So I just wanted to really, really double check when I go to put this on, it won't fit. Yeah, that doesn't fit at all. Okay, so I did that because this one I have a part number for it. And so we're going to go get the data sheet for that part, and we're going to make this work correctly. Where are we at? We want a Johnson 142-0711. Basically what I'm going to do, I'm just going to get the data sheet, and we're just going to make a correct footprint for it. Here's the Cinch website, which I think Cinch acquired Johnson. I'm trying to remember. Johnson has two names in it, and I always think of them because that's what my SMA wrench. That's who my SMA wrench is from. Okay, let's do a. If we look at the drawing, that's exactly what I want. Do they have a land pattern? They do not. Really? Okay, I take that back. This is not exactly what I want. That doesn't even look like my part. I'm trying to figure out. This drawing is not. That's not it. Did I? 142. Yeah, that's not it. Did I type it in wrong? Nope. Yes, I did. That's what happened. I don't want a distributor site. That looks much closer to what I have. I'm going to fab the board again. I forgot to come back over here. Nope. Let's try that. I am going to fab the board again. But I might still try to bodge this one up a little bit and see, because I really want to know what the impedance of this trace is. But I am going, I mean, it was all, it's only like, it was literally like $10 or $12 with expedited shipping from Osh Park. Wait a minute. Why am I? Okay. No, that's not right. What in the world? Uh, 2056, 699. 2056, 699. Just a moment. Just a moment. Just 677, 381. All right. There we go. Oh. Yeah, I wish After Dark was faster. Or did they finally introduce Swift for After Dark? I think they might have, but I rarely use it. But yeah, I wish it was a little bit faster. Okay. Anyway, here's the part. I'm going to close this. We're going to open up this. This drawing is still terrible. This is not what I wanted. I don't understand what I'm looking at. Is there another... maybe there's a better drawing number? Nope, that's not any better. I do want the 3D model though. Do they not offer it in step? Let's download that. I'll take that for sure. What about this? Oh my gosh, you are just killing me. No, that's still the... Why does a connector have a cover sheet? Okay, well that's completely useless. This is what it gave me. Like... So what on these resources, no, yeah, on the 3D model, they said download 3D model, a 2D, do they have like a DXF? What about an SVG? Let's try this. Nope, that's not the one I want. Let's delete that. This might actually be closer to what I want. Oh, wait. Ugh. Hold on. I need to close this now. Okay, none of these are what I need. Why can't they just give me a land pattern? This is ridiculous. Okay. I can't believe this, because it's like... These drawings are terrible. I'm trying to understand. Okay, so I guess what this is actually is, if I look at it from this way, that's what these two posts are. Okay. Okay. We can work with that. I get it now. So what I'm going to do is let's do a... No, that's not what I wanted. Let's actually go to the PCB. This super complicated PCB that took me hours and hours to design on conference calls. Okay, I had a feeling that was going to happen, so let's move this now. And then I'm going to click on my component. So let's do footprints, click this one. I'm going to do edit to bring up the edit window. Then I'm going to do edit library footprint. Okay. Now we can do this. This part is the easy part. I did want to look one more time. They don't have a cinch. Yep, okay, we're just gonna make our own. So then I'm going to say, let's right click, save as. And I'm going to put it in my library. Oh, that's not what I wanted to do. That's okay. Because now I can look for a 73251 in my library. And then I'm going to come up here to footprint properties. I'm going to change this to Cinch. Actually, I'm going to put Johnson because I actually think, no, we'll say Cinch. Why not? 142.0.7.1.1.182 edge mount. And then we're going to make that the name. And then for description, we're going to delete this because that's weird. I don't know why they did that. And then over here, I'm going to grab this and put this into the data sheet. There we go. So now I can make this more small. And we can make this more small because I'm going to want to use that, I'm sure. So we can make this really, really small. No, we can't. All right, well, we don't need it. So let's just do view and turn off the footprint tree. Okay. So item number 1. According to Mr. Datasheet, of course, they don't give us center to center, so that's nice. But we know that from edge to edge is 2.5 or 0.25. That's gotta be inches. Yeah. So what I would like to do is from the 0 point, I'm going to draw a line on user drawings. And I'm just going to go like this, because what I want to do now is I want to edit this and then say I want the length to be 0.25 inches. And then I want to make the start point on the Y be half of that, which is going to be 3.175 here. Okay, so that is, that's hilarious. That is the full width of this actual connector. Whatever. So then I will use the micrometers to find out that this post is 0.8 millimeters. They say 0.32. So we're going to draw another line. I'm going to do this, and then I'm going to draw this line. Then we're going to edit this line. Actually, why do I keep editing just out of a habit, except the length is not on this one. Of course not. And I want the length to be 0.032 inches. Right? And then I want this line. And we'll just kind of, I don't really care where it goes. All I care about is this part. And we're going to do the same thing. We'll do 0.032 inches. Hey, Proton Fig. How are you doing? It's been a long time since I saw your name pop up. Of course, it's probably been a long time since you saw my name pop up, but, you know, that's how that goes. All right. So, now, this pad, we need to make this way more small. So let's go with the pad size. I'm going to leave it, well, I might even shorten it. I might leave it as long as it is, just because why not? In the X, it's going 5 millimeters. Okay. In the Y, so in the Y, we really only need like a millimeter. So let's do, what's 2.54 divided by 2? Let's do 1.27 millimeters. All right. And then I want that to be on the, let's see, X, Y, is it this one? Yep. We want it to be there. So I'm going to edit this. Could probably have done it right there. And on the Y position, I'm going to put it right here. All right, so let's do that on this one. Let's make its Y to be right here, and then let's make its width 1.27. All right, so the front and back should now be much closer to each other. I'm very tempted to make the launch smaller. Santa. Long time no see. Ah, that's very good. Very good. Hey, Weave, I just saw that you followed. Thanks for following. For those on YouTube, just so you know, I'm streaming on Twitch as well, and so I'm responding to chat over there. My bad. Okay, so this is probably going to be positive, whatever that number is, and then I want this to also be 1.27. Yep. And then can we do both of those in the property manager? I know I can do this one, and then we can do this one, but I want the positive number. Okay. So that's looking pretty sharp. Then I'm going to move this pad. Actually, that pad is going to go here, and this pad is going to go there, and this pad is going to go, or via, is going to go there. And then this one is going to go here on the positive side. And this one's, can we select them both? Yeah. Okay, there we go. So our vias to the other side of the board are done. ESD killed your macro pad. Aw, that's a shame. There should be a song about that. You know, like Video Killed the Radio Star. Stop it. Stop it. Stop it. Stop it. Stop it. Okay. Now, what I would like to do is understand. Okay. The last thing was I wanted to double check. Yeah, these are 4 millimeters. So what I'm worried is from the board edge, so from here to here, well, that's probably going to be okay. All right, let me save that, and then let's go back to the Pasiba. And I want to, oh, no, we'll do it in the schematic, because the schematic is our statement of record. Oh, I always forget about this hotkey. I'm going to press F for footprints, and I'm going to click on the footprint library. Now, when KiCad 8 came out, I had some opinions about the change to the footprint chooser. However, I've come to recognize that I may have been, I don't want to use the word wrong, but I might have been wrong about it. So what I realized is, and this won't work, or I don't know if this will work, but I realized you can actually type like cap 0805 and it comes up with something. Or you can do like, what was I thinking of earlier? Or even, yeah, cap 0805 hand, and it actually filters really smart. And the thing is, and I don't know if this is an intentional design, but it reminds me of how distributors will they have this nomenclature for parts. So like a ceramic capacitor will be 4.7 U, or yeah, U 100 volt 0805 X7R, right? But it always starts with like SIR. But it sort of reminds me of that. So like I can do SMA and then I'll do cinch, which I could have just done cinch, and it filters and finds it correctly. So I'm actually happy with it. Oh, that's a tough word to use. Do I have a link to the probe? Yeah. So I'm going to give you a link to the I'm going to give you a link to the Hackster article I wrote, and then in there is a link to the person's project. I'm only doing that because I don't want to scroll through and find it. Yeah, that's why. Hey, Christian, good to see you. Proton, you say you have a new love. You love your vampire? What's a vampire? you got the radio star song. Radio star song. Okay, I'm not gonna. Fortunately, I don't talk for a living, so it's okay when my words mess up. I did it again. I'm gonna press F for footprint. Okay, I just remembered in the last month I have seen like 10 people complain about this in KiCad, and I'm actually shocked by it. So I keep seeing people say to make KiCad usable, go into the preferences and uncheck center and warp cursor on zoom. And I'm baffled why anyone would uncheck that, because all you do is, uh-oh, what's going on? Because wherever the cursor is at, that's what gets recentered. So if I zoom all the way out and say, oh, well, I want to see this SMA connector, I hover over that, and as soon as I start zooming in, it becomes the center of the screen. And then I can zoom out and then zoom in over here, right? Now, I say that facetiously because I think what some people want to do is they want to zoom out and then like use like the second mouse button or scroll bars and pan around and then zoom in somewhere, which is fine. But to me, it's just so much faster to hover over the area you want to zoom in and then zoom. So I'm confused why you wouldn't use that, but I would recommend using it because, I mean, for this schematic, it's really silly, but it makes navigating through a schematic, and especially a PCB, so much faster and easier. It's also shocking to me because it's like how every other CAD program works. So, uncheck to match other CAD behavior? I mean, it's how almost every CAD works. Or, let me rephrase, it's almost how every CAD I've used work. Anyway, that's my comment for the day. Okay, so now, come on, come back over here. And I do actually understand how it can be disorientating at first, but I think what people miss is, like I said, you just have to realize what's going on. Like that's why I don't understand your comment to work like every other CAD. Every CAD I've ever used does this. That it's how they all work. So, or all the ones I've used. Maybe there's something out there that doesn't. I got to take that drawing back off. All right. See, that is not the right model. Oh, because I didn't change it. That's why. Let's go back to the footprint editor. And of course, this is only going to change on my copy, but eventually KiCad will allow this to work correctly. So I'm actually going to delete that. Oh, I didn't do anything with it yet. Let's 7-zip export. Really? I'll have to think about it. I feel like it works the same way, like especially like in Fusion. Actually, okay. Maybe I do understand what it is. I'm going to try something in just a second. I want to get this done, and then I'm going to try something because maybe I do know what you mean. In which case, maybe I've just gotten used to it. I'm looking for, oh, I hate how this doesn't. That's what I should do, is add a path. So this is easier. I feel like I figured out an easier way to do this the other day, and now I've completely forgotten. Oh, sweet. Oh, man. I was going to say, it almost never imports correctly. Wait, maybe it did. Okay, I know what I need to fix. I think because I have this stuff and the courtyard. Let's see if this makes... No. I don't understand why it is... Oh, okay. You know what? I know what's going on. I need to ignore that because there's no PCB, so the 3D viewer is making up an edge. So we do just need to move this like to be like right, maybe let's go 2575. 958575. Okay. All right, let's save that. Yeah, I think you guys are right. Well, I actually know I know you're right. So if I uncheck this and zoom out, and then say do this, okay. I thought that's how it always worked. I didn't even notice there was a difference. I don't see the difference. So, and maybe that's what it is. Maybe it's only on small changes. It's a little more distracting. On a big change, you probably don't notice it. But if you try to do like zoom to here, zoom out, and then zoom to here. Okay. Okay. How high frequencies do these are supported on these connectors? So these SMA connectors are technically rated for 18 gigahertz, but I doubt I'll doubt, especially on this board, they'll get anywhere near there. So Christian says the zoom in KiCad is wonky, catches you off guard. Okay, yeah, I'm struggling because I don't think it. I guess I've just gotten so used to it that it just surprises me that people. I don't know. I'm really used to it, so it just never occurred to me to turn that off. All right. So that's still the wrong model because I think I forgot to do update footprint. We'll update all these footprints. And then we'll go back to the 3D viewer. Yeah, that's not going to work. All right, let's go fix that. What am I doing? I want to fix the footprint, but I don't have the footprint open. So let's do edit library footprint. Yeah, I guess what I've gotten so used to the center on zoom behavior that that's how I just expect it to work now. And what I'm really surprised by is that I've never felt like it's different than what like Fusion does. Although I think I'm understanding what you guys are saying, but in my mind, it's not that different. All right, so if we do that, then this does need to go up just a little bit. So I'm going to do this. I'm going to do a save, and then we're going to come back over here. Nope, we're going to come back over here. I'm going to do update footprint. We'll do the same one, update, close, and then we'll go back to the 3D viewer. And then we do need to get to the edge of the board somehow. Okay. What was the suggestion earlier? We should put a piece of, wait a minute. Oh, I know I'm getting so confused. Okay, I am going to put, yeah, let's do the silk. I'm just going to put silk right here. All right, so then if we come in here, the only reason I'm messing around with this is because I don't want to have to redo this every time I use this footprint. All right, that's pretty much on top of the silk, so I'm going to take it. And then I think what I want to do is take this pad, this pad, this pad, and this pad, and we're going to, actually I'm just going to make them slightly longer. So the X, if I make them 528, nope. What is, because if we go another 1.27, that's way too big. What about a plus half of 1.27? That's what I want. So we're just going to make all of the pads this width, length, whatever. All right, and then let's turn the front copper off. All right, and then we'll turn, and then we'll do the adhesive and the paste. Interesting. Why didn't that one update? But the others did. Oh, because there's only one pad. One. All right. Hey, Silent, good to see you. Cags, been a long time since I've seen you. Long time no see, Sharp. Yeah, Sharp is not how I would explain or describe myself today. All right, so let's do, I meant to right click and do update footprint. Yeah, I'm feeling really silly about the whole, ooh, those are, okay. So here's what we're gonna do now, because I'm tired of going back and forth and whatever. I think if I come in here, nope, So if we move this to 525, and then go back here. Nope. Basically what I want to know is what's the offset, and then we can go into the library and fix it. Nope. Uh, 575. Nope. We're getting close. If I had a better drawing, I could probably just look at that. All right, so we did 585. I guess I didn't need to change that because it's going to change in just a second. So then I'm going to come into here and we're going to make this 585, and then we should be able to make the, I guess that's all we have to do. And then now let's do update footprint. Update, close. There we go. That's much better looking. All right, so the good news is those pads aren't anywhere near where I thought they would be, and I just now realized why. So that's fine. But all I need to do now is make them biggers. Hey, Ramones, welcome back. Good to see you. Hey, GB. Man, that's 2, maybe 3 weeks in a row. That's awesome. For those watching on the YouTube, after the ad, you might check to make sure that we're all the way up to the thing. I'm actually going to put a Twitch link because my YouTube is buffering like crazy. So we'll just do that. I don't know, am I buffering on Twitch? Or is it going through okay? I mean, it's all green. Let me double check OBS real fast. It says I haven't dropped anything. Yeah, there's something up with YouTube tonight. So, okay, yeah, that's actually really telling right there. These pads are not going to work as is, but that's okay. That's okay. Man, I've screwed up something big. I've really screwed something up here. What is going on? If I go back to the footprint, what's bothering me is no, I don't shine my head in the morning. Okay, maybe I'm just having issues with YouTube. Okay, I'm having a minor my brain not work moment. We should just move this literally to the edge of the board. and move this to the edge of the board. All right, refill that. And then I'm just going to move the connector back. In fact, for the purpose of rendering, yeah, we'll go fix it in the library. You know what? I got to do it this way. Let's do side by side so this will be faster. Okay. So if we go to the library, oh, okay. We don't really get side by side. That's right. No. What I was going to do is edit this to find out what it's supposed to be and then go fix it in the library. So if I move this back to 525 and say, okay. Nope, not quite. So then if we just go to 5, I'm going to go with 5. 5 is going to be close enough because slight gap, but more realistic. And then that gets us on there. So what we really need to fix now are the pads. So let's go do that in the library. So back over here, first we're going to fix the 3D model. All right, and then my problem is I drew the pads. I said, oh, well, the thing goes to here, which is the end of the connector, but I want my pad to be in the center of the connector. So if my pad is 0.032, I want to move, select all, I want to move this X XY. I want to move the Y up plus 0.032 divided by 2, right? Because that should put that into the center. And then down here, I want to, oh, the other one should have been minus. Minus 0.03 minus 0.032 divided by 2. Oh, shoot. All right, and then this one we'll do select all, and we'll plus this one. Let's see how that works out. If someone is exposed to too much, does it change chemistry for a short period that affects other electronics, like people that are communicating or climbing towers? Not really. RF is non-ionizing radiation. However, it's still high energy, and so it won't, say, cause cancer like a radioactive device with ionizing radiation would, but it can literally like cook you. And so, like if I had a really high power 2.4 gigahertz transmitter, I definitely would not want to stand in front of it. Would I be okay? Probably, but that's a lot of energy that you probably don't want to have just pointed at you. Even though, like I said, even though it's non-ionizing, it's still a lot of energy, and things happen with energy. Now, once you're away from the tower, and because of the power law, it doesn't take long before you get to a point where it's trivial, like very, very short distance. So yeah, so somebody climbing a tower. Now, the other thing to keep in mind is somebody climbing a tower is not in the radiation pattern of the antenna. And so their exposure is extremely low unless they get in front of the transmitter. So it's a I'm trying to think. There's multiple elements at work there. But the important thing to understand is, it's, like I said, it is radiation. There's lots of kinds of radiation, but it is not ionizing radiation, and that's the difference, like compared to, say, something that's radioactive. But yeah, it's still a lot of energy. You got to be careful. I mean, there's a reason why RF is in microwave frequencies, and your microwave uses a magnetron around 2.4 gigahertz. That is not an unintentional coincidence. All right. Oh, I forgot to update the footprint. So let's do update footprint. Update. That barely moved. That barely moved. Did I not save it? Oh, heck. Why don't we rethink what we're doing here? From the pin... Yeah, wait a minute. I didn't think this through. I know what I wanted to have done, but I didn't do it. Okay, so based on the data sheet, we know that the distance from end to end is 0.25. So I'm going to go back, I'm going to do my drawing. I'm going to do a line starting at 0, and then we're just going to pick a point, and I'm going to say I want this to be 0.12 or 0.25 divided by 2. Oh my God. 125 inches. Really, James? Come on. Okay. I know I'm getting confused. User, line. All right, I want its length. That's why, because the length isn't in the properties manual box. Bubbles on your back, yeah. Is that connector a box mount? Yeah, although I don't know what box mount means. Unless you meant, is it like vertical versus horizontal? Okay, 0.125 inches. Let's do that. And then line. Negative 0.125 inches. Yeah, just to finish up on the RF energy thing, I mean, definitely go talk to a doctor. Because, you know, okay. So where I messed up was, I want the center of my pad to be at this X coordinate. But that's not where these ended up. So what we should have said is the position should have been not X. What's the Y? The Y is here. So these Y's should have been here. That's where I wanted it. So what I'm going to do, just to make sure, I'm just going to save this and then come back here and then do an update footprint. You know what? I'm really, really glad I downloaded the 3D file. I have high confidence that it's correct. I should probably make measurements to verify, but I'm going to guess that it is correct. Well, that doesn't look like it changed anything, does it? No, that did move. But the pad is still... Okay, now the pad's too far. Okay, so that did what I wanted it to do. It put the pad right in the middle of this edge. Oh, that's what it is, because I want the middle to be right here. Duh. So... God, I hate mechanical stuff. I really, really don't like this. Yeah, I should actually... Do I have it available? I got this at Hamvention a couple years ago. And then actually last year, the guy that I bought this from, he was... so it's an actual RF sign from somewhere. Huh. Right here. That's the price tag. It's a green sticker. Anyway. So 2 years ago, I got that at Hamvention in Dayton. And last year, the same guy was selling reprints of that sign because they were so popular. And so I was with a group of like, I don't know, what are there, 5 of us? And I guess there was only 2 guys. 2 of the people were new. This was their first year at Hamvention, and they both bought the signs. I think they both bought a sign. But yeah, that's one of my favorites, actually. Anyway, okay, so here's the deal. I have this thing all the way up here at 3175. We need to back that down by... Yeah, wait a minute. What's the center point here? So if I had said if I had said go up, so now we're at the center. Now I need to come back down. Is it 0.032 or half that distance? That's where I'm not sure. You haven't been since 1990? Yeah, I've gone the last 3 years in a row, and I really enjoy it. It's actually a really nice getaway. I'm totally missing something here. How do you find the center there? How do you find that center? Or did I just press? Senior Snave, Jove over on Twitch. Thank you for the follows. Welcome to the stream. Oh. Did you guys see the sign? Oh, I know what I did. I hit the wrong button. Okay, never mind. I'm just out of practice. Sorry. Just out of practice. I did not attend the Oshkosh Air Show, but my friend did. I didn't realize. I think I had heard about it before, but I just recently started watching a YouTube channel called Pilot Debrief, and he did a video on an accident that occurred recently. I don't know if it was last year or like in the last couple of years. And so I had just heard about it, and then it turns out a friend of mine was there, and I was like, "Oh, that's that thing I just learned about." Okay, I'm gonna fire up Illustrator because I'm not braining this correctly, and I'm not sure why. I need a vector program. Yeah, actually, so not this year, but the last 2 years, I saw vintage computers at a couple of booths in the flea market that I was like, I'm kind of interested in those. And then this year, I was like, I am not buying another oscilloscope. But if I saw a vintage computer, I was going to get that. So I ended up buying only one oscilloscope and no vintage computers. I need to change my streaming setup in the lab, and when I get that reset, I am going to show off the scope that I got. All right, so I want 0.25 inches by 0.25 inches, and I want that because I'm trying to recreate this. So that's the outer dimensions, and then they have another rectangle that is, let's see, the X is 0.032 inches, 0.04 inches, kind of irrelevant, but sure. And then let's make these like 0.25 point, there we go. And then that's kind of somewhere over here, I don't really care. What I do want to know, though, is where is the center? So that's here. And then from here to here, we look at this width. Where'd it go? Where'd it go? Where'd it go? Where's info? This width is 0.125 inches, just like we expect. However, what I really want is where is the freaking center point of this one? All right, and then I can draw a line from let's just draw a line from here to here. Although I don't know if that's really where I wanted that one. Yeah, that line's not right. So then if I draw a line from here, oh, nope. From here. Oh, what are you doing to me? Stop that. Stop it. Stop it. I don't know what oh. Whoa, what happened? Where'd all my things go? Okay. I want to draw a line from right here to intersect. Okay, so that distance is 109 inches. So how are we getting to 109 inches? So if I'm at 1.25 inches long, and my other box is 0.032 inches, and I'm at 0.109, what's the difference? 0.125 minus 0.109, it's half this distance. It's this distance, 1/6. Okay, but here's all I care about is 0.109. My brain just did not could not see that a minute ago. Yeah, I am not buying another oscilloscope. I'm not. I really did. I really said I am not going to buy another one because. Did I buy one last year? I bought modules for my oscilloscope. I bought a tuner. I don't remember. But anyway, the one I found, it's a 7000 series tech frame. So like my 7704 that I got from the electronics flea market years ago in the Bay Area. It's a 4-bay modular frame. Well, I saw a 3-bay version of that modular frame, and one of the modules was a counter. And I was like, oh, I want this counter. And so they had like $120 on the maybe $120, $125 on the scope. So I took a picture of the booth and the booth number, really important at that location. And I was like, okay, now I'm going to just walk around and not buy an oscilloscope the rest of the day. So later that day, when I decided to buy the oscilloscope, I went back, and on my way there, I was like, I'm going to offer $80 and see if he'll take it. And I got there, and I was like, yeah, I want to buy this scope. And the guy that was standing there said, oh, I'm sorry, my buddy, it's my buddy's, but he's not here at the moment. And I was like, oh, well, do you think he would take, and I looked down, and the price was he had already marked it down to 80. So I was like, okay, I'll take it. I was just like, yeah, okay. I take that back. That's not quite how it went. What happened is, now I remember. What happened is I was going to offer 80 to get it for 100. And I looked down, and he had already marked it down to $100. And so I was just like, okay, I'll take that. And it's like, because it was already where I wanted it to be. The person that I needed to negotiate with wasn't there, and the module itself, like, and not that I bought it because of value, but the module itself working sells for like $75. So I got another time-based module. The vertical module had a vertical module, 2-channel. One of the channels is blown, so that was kind of a bummer. But the frame works and the counter module works, so I'm really happy. So it was just one of those cases where I'll bet if he was there, I would have probably gotten it for 80. But I'm also not super, it's like, it's only $20. I mean, it's already, I would have actually paid the $125 if it wasn't already marked out. Like, if he didn't want to negotiate, I would have paid $125, probably. So anyway, I'll have to show that scope off sometime, or at least the counter module. I think it's kind of cool. I mean, you got to remember it's a late 1970s, early 1980s design, and entirely in discrete components. It has some 7400 series logic chips, but in discrete components, just using vectors, it draws numbers on the screen, and that just blows my mind away. Like, it's so cool. Okay. That's what I was trying to get to. That's what I wanted. And now that I've done this, I want to make those pads bigger. Yeah. Yeah, I just want to make the width just a little bit bigger. So let's go do that, and then we can call that done. So we'll select all. What did I do on the, so this is X, that's Y. What's half of, let's just do that. All right. And then we'll come back over here. So I'm not going to do it tonight because my printer is in a different location, but I will print this out and then view it to make sure that I'm going to print this out and connect it, or make sure that my connector mates up to it correctly. So, hey, NioCat. Haven't seen you in a long time. Welcome back. Or maybe you haven't seen me for a long time. I keep forgetting that kind of maybe how that went. All right, so that looks good. The back side, that looks so much better. Other side should be good too. And then we've got one more thing we got to fix. But okay, I'm calling the connector, the footprint done. That's check mark.
There was much rejoicing.
Oh, yay. Now, item number next is already fixed. Yeah, so the only, okay, let's refill the zones. Yeah, no, that looks good. Okay. Yeah, I was gonna say, so the only other thing we had to fix was on the first revision, I left a little sliver of copper like right here for reasons. And I realized that was going to probably short out the conductor on my connector. So we needed to eliminate that, which filling in the zones did for us. Okay. Let's make sure that Oh, I know what's going on. Okay, I finally figured out what's wrong with my thing. Okay, all right. So in that case, what we need to do is we need to fix the silk screen. So let's do a flip board and then do back silk, edit. Or is this a, yeah, this was a key buzzard. So we'll change this to number 2. There we go. And that's it. This is ready to go. Oh, we should run DRC just to make sure it's happy. Just to ensure happiness. Violation. Wow. It's really not happy. Yeah, this is actually a little bit of an issue. You see, the problem is, in order for me to get a 50 ohm trace, I had to make the track this width, or in the case of this orientation, this height. DRC is mad because the edge of this is too close to the edge of this. However, I can't do anything about that. Let me save, because I'm going to try something, but like, just to show what I mean is if I move this here, yeah, it's mad. Okay, it's even mad about the connector itself. I have, the connector is not ideal, and the reason, I know the reason, is because this connector is probably meant for a 4-layer board, which would have resulted in a less wide trace. So, hey, Biznot. Why does this look slightly thicker than the other one? Oh no, it's the same. So, this is sort of a doesn't matter. I don't really have a choice. I guess I guess what we could do is make the ground pads slightly thinner. Oh, you know what we got to do? I got to move this via. It won't solve our problem, but we got to fix that. I don't want to make the pads smaller because I still have to be able to solder to it at some point. If you're breaking the rules, change the rules. Oh, I like that. Yeah, that's... Earlier I was hanging out in the Adafruit Discord and I realized I was giving somebody basically the opposite advice of what you normally do for decoupling caps. But it was also a situation where it's like, well, because of the way that this microcontroller's power pins are routed or pinned out, you kind of have to do it this way. And it's like, but it's like, yeah, if you understand the intent, then it's probably not a big deal. But I could totally see how somebody new would be like, well, wait a minute, aren't you? Because like the general, the thing that everybody repeats without actually understanding why is, oh, put a 100 nanofarad capacitor on every single VCC pin. And while there is some truth and reason to that, it's not necessarily a rule either. Yeah, see, the thing is, this separation should be about that much, but I'm really tempted to, I'm just going to leave it this way. I'm just going to do this and then see what it comes out as, knowing that that's probably wrong. I mean, it's not like I'm going to solder it really well, so there's going to be a discontinuity there no matter what. Hey, Jim. Good to see you. Video tutorials for KiCad. It's out of date, but Contextual Electronics or Chris Gamble, years ago he did Getting to Blinky. I think it was KiCad 6. So the core concepts are still the same in 8, but that's to me is one of the best ones. A lot of people recommend Phil's Lab. He has like 1 hour long tutorials on how to design STM32s with KiCad. I feel like that's not actually a good tutorial to learn how to use KiCad, but other people seem to really get a lot of value out of it, so that's another option. I mean, yeah. I've thought about, well, I'm not making KiCad tutorials anymore, but I had thought about redoing something like the Blinky one, but anyway. All right. We're just going to go with it. I'm just going to go with this and see what happens. I gotta pause this. It's so back. It's so out of date. Between 4, I would say 6 and 8. It has there. I mean, between 4 and 6, I think if you have tutorials based on KiCad 4, that's going to be those are going to be tough to follow. But for, or not for, starting with version 6, 6, 7, and 8 fundamentally have the same core concepts and UIs. Even 5 isn't terribly different. It's just that 6 is when they really unified the hotkeys and stuff. I feel like 6 was like a really good. 5 was get a bunch of features in that had been lingering for a really long time. 6 was a cleanup. 7 focused on PCB. 8 focused on schematic. Anyway, yeah. Okay. I'm just babbling. Okay, I'm happy with this. What I'm going to do now is let's go ahead and do the file output Gerbers. Yeah, I actually started or tried to start with version 4, and I used to get so frustrated. It was just there were just so many things that just drove me insane. And then with 5, I was like, oh, this is pretty good. And then since then, once I started using 5, that's when I stopped using everything else. So what's this one? Oh, it's probably silk. Okay. I'm happy with this. All right. I was thinking about starting this pulse generator design, but I don't think I'm going to tonight. I stressed myself out with this footprint way too much. So I think we're going to stop here for now. Probably end up having a longer stream next week, because hopefully next week I'll be able to have my scope set up, and then we can do something fun with that. I was going to look into something really quick, but
it's more work. But you know,
oh, why are you? Don't be talking. Okay. I don't know who either of those are. So I will actually show you what I'm going to do, but like I said, I'm probably not going to do it today. Oh, did I already close it? No. Why did I do that? Aw, James. Where did I put it? All right. Move any mountain. So I found this, I think it was actually on the EV blog forum. I found somebody who found this device, which is a high-speed silicon germanium or SiGe comparator. And the thing that is really interesting to me about this part is its rise and fall times are in the 35 picosecond range. And that's really important to me, because assuming a Gaussian or first order response, 0.35 divided by 35, I don't know how to do exponents. 0.35 divided by 35 x to the negative 12. Oh, it won't let me do negative 12. Okay. Where's my phone? Okay, so 0.35 divided by 35 to the negative 12 is 10 gigahertz. That's not right. Yeah, it is. I won't get nearly that fast, but I'll get fast enough that we'll be able to accurately see how a active probe, such as this one, can reproduce a really fast step or edge response. And so I want to see this using this fixture, right? So what I envision is I want to build this little pulse generator, plug it into one side of here, and then put my probe onto my strip. And then that way on the scope, we can see the original pulse, put the probe down, then we'll see the loaded pulse, and we'll see how the probe reproduces it. And then that way we'll get a really good idea of how well this open source active probe works. The really cool thing is, so on a VNA, this has about 2 gigahertz of bandwidth. The scope that I have from RNS right now is 1.5 gig, and I have a 1 gig active probe from RNS. So we'll be able to really get a really good idea of how well that works. So, hey, Upgrade, I'm going to assume, thanks for the follow, welcome to the stream. I'm going to assume you are a Idiocracy fan. I've watched that movie like 100 times. And I've been watching it ever since it was in the theater. I think I even saw it in the theater, maybe. I owned the DVD for the longest time. I rewatched it the other day. I remember it was I was sick at the beginning of July, and so I was watching Idiocracy, and I fell asleep. When I woke up, the credits were playing. And so I kind of I got up and like took medicine and stuff. And I came to realize after like a decade of watching the movie, there is an end credit. There's a scene after the credits. And I was blown away. I had no idea. For all this time, I did not know there was a scene at the end of the credits. So, which, today it's like everybody looks for it, but back then we didn't know. We wouldn't know to look for that. So anyway, so here's probably what we'll do next week, because maybe we'll do this next week. I want to actually design this circuit. Somebody else has already done one, but he didn't open source or provide his schematic. So I'm just going to follow the application example that they have and basically create a repetitive create a repetitive clock signal that goes into this comparator, trips it, and then causes this thing to keep just basically, going up and down. So, yeah, I've got a VNA. I've got a couple, including the Nano VNA as well. But I've got a real VNA and a USB-based, a Pico. So I have a Rohde & Schwarz ZNLE, which it only goes down to 1 megahertz, but it goes up to 6. However, my AutoCal only does to 4 gigahertz. And then I have a Pico VNA, which the VNA Workbench Wednesdays episode that I did is what I use that for. Wednesdays, Vector Network Analyzer, YouTube. That one I think is either a 6 or 8. I don't actually remember. I think I have a 6. That one's actually a really good one for a USB-based instrument, but their software is kind of wonky. And then I have the Nano VNA, which is like it's a 3 gig. I think it does 3 gig, which those are basically just using up converters to get a wider frequency range. The unit itself I never use, but I never use the UI on the unit. I use NanoSaver, which is the software that talks to it, and it actually, I wish NanoSaver worked with the Pico VNA, but that's a whole other story. So anyway, this is the next project I want to do. I was thinking if this footprint had only taken 30 minutes, we would start on this, but I don't want to start this tonight. Because I need to look a little bit more into this chip and what's involved to get it to work. but I think this is going to work out as my high-speed pulse generator. So, all right. I want to thank everybody for joining. Had a really rough start today, but we got there in the end. I will be back highly likely next week. And yeah, what am I looking for? I'm looking for this one. Usual stuff. If you didn't know, I do have a show on YouTube called Workbench Wednesdays. So go and check that out. There was an episode last week on the Picoscope 7. And then I am legally required as a streamer to have a Discord. So I'll provide a link to that as well. For those that are joined on Twitch, we're going to go see our friend Sid. And for those that are on YouTube, we will see you next week. All right. Thanks for hanging out. Remember, try to find time to do something you enjoy. And if you do, share it with other people. All right. Take care. Bye.